So the solution to this particular problem of Green's approach was it was developed at Stanford, okay, and that approach is called as strips approach, okay. So to handle complex problem domains, we need a mechanism that does not require large number of explicit frame axioms, okay. You will go mad writing the frame axioms to specify the current situation or the current state that you can see in the realistic world, okay. So we really do not require a large number of explicit frame axioms to write explicitly. So then what? Okay, so the Stanford Research Institute problem solver was designed, STRIPS. It was designed, so it was a planner. It was used in Shaky, one of the first robots built using AI technology, which is the action centric representation. For each action, it specifies the effect of an action. So this strips, it was designed by Stanford Research Institute for a very famous robot, in olden days, a very famous robot that they came up with called as Checky. Okay, now how this strip solves the problem of Green's approach, the problem faced by Green's approach. So basically, strips representation for action, it contains three lists. Okay, the first list is called as precondition list, or simply P, capital P. Okay, so what this list contains? So precondition list, it holds the list of predicates which remain true before an action or operator is applied. Okay, second, add list, it contains list of predicates which are true after the action or operator is applied. Okay, third, there is something called as delete list. Now this is very important. Okay, it contains the list of predicates from the precondition list which are no longer true. Okay, so in the preconditions, okay, after the action has been taken, delete list contains only those predicates from the precondition list which are now no longer true, right? So your ramification will be solved here. And the most important thing, what about the frame problem? Anything or any predicate that is not specified in one of these three lists is assumed to be unaffected. So if something is not, if some predicate is not mentioned in this one of these three lists, that means that thing is unaffected. The change has not occurred to that particular thing. Okay, so strip style operators for block world problem. Now let us consider our same block world problem and how can we design the strip style operators for that, right? So you have a list here. The first operation here is a stack operation. Let's say x is stacked on y. So when I say x is stacked on y, it means the precondition for this stacking should be that the robotic arm should be holding x. For x to be stacked on y, robotic arm should be holding x, and block y should be clear. There should be nothing on top of it, right? And that's why for stack x comma y, the precondition here is block y should be clear and and the robotic arm should be holding x. So this is the precondition list. Now once the action is taken, okay, of stacking, what happens now? What are the effects of the action? The robotic arm is empty. Okay, the actions, the post conditions or effects of this particular action is that robotic arm is empty. Okay, robotic arm is empty and block x is now present on block y. So add list contains the effect of the action. So arm is empty and block x is on y. So P means the precondition list, A is the effect or the post condition. Then what is delete list? Now the action is already taken. Okay, now that the action is already taken, you have to consider the precondition list and find out which are the predicates or axioms in this precondition list which are no longer true, and only those which are no longer true from the precondition list, those you have to add to the delete list. Okay, so let us see what is the effect of taking the action. Okay, the effect of taking action is simple. Robotic is arm is now become empty, and block X is now on top of Y. Okay, so is block Y still clear? Is block Y still clear? Is your block Y still clear? No, now X is sitting on Y, so block Y is no longer clear, correct? Block Y is no longer clear. So as a result, since this predicate precondition, now it is false after the action is taken, so add this to the delete list. Why? Because this clear Y is now, after taking action, it is no longer true. So add this predicate to the delete list. Similarly, after doing this stacking, is robotic arm still holding block X? Is robotic arm still holding block X? No, X is on Y and arm is empty. So that predicate is also false. So holding X is also false. So that you add to the delete list. Understood? So in the strips representation, as we have seen, there are three lists. One is P, that is precondition list, which contains all the predicates which should be, or all the predicates which should be true for an action to execute. Delete list contains add list precondition list is done. Add list contains all those predicates which are now true after the action is already occurred. Then what is delete list? So delete list contains only those predicates from the precondition list which are now no longer true. So since clear Y is also not true, holding X is also not true, both are written here. So this is the stack action. Similarly, we have the list for, we have the strip style representation for pickup, unstack, and put down. Okay, I would like you all to go through the PPT later on and check this for yourself. I think I'm clear with this, right? So let's go further. Now, what questions you can get for exam on strips? Okay, so they are going to give you a paragraph, or they are going to give you a situation, and they are going to ask you to represent that situation using strip style of representation. Okay, so we have taken up one question. Okay, this is taken from one of the papers. It's called as a spare tire problem. Okay, so it's a problem of changing a flat tire. What has happened is, there was a vehicle, car, okay, and on the way, one of the tire at the axle of the car, it became flat, punctured. Okay, so the actual problem here is, you have a spare tire in the trunk of the car. Okay, or the trunk of the car, and the problem here is that you have to remove this flat tire from the axle of the car, then remove the good or spare tire from the trunk and place it at that particular place on that particular axle. So remove the flat tire from the axle and replace it with the good tire from the trunk. A very simple problem. Now to keep the problem simple, okay, all the other jargons, for example, nuts, tightening of nuts and bolts and all, you ignore that, we are not going to consider. Fine. And another specific thing they have told you, that suppose the tire got punctured and you are somewhere in the dense forest, your car is somewhere in the dense forest, and suppose maybe because of certain reason you have to leave your car unattended, so that you can come tomorrow morning back and do the repairing or get the mechanic or whatever it is. Okay, if this is a situation, then they have told you that the car is in a very bad neighborhood where there are robbers, there are robberies which take place. So if the car is left unattended overnight, okay, what will happen is the tires will disappear. So basically this is the overall problem that they have given us. Okay, so I will now read the problem more precisely. The goal of the problem is to have a good spare tire properly mounted onto the car's axle, where the initial state has a flat tire on the axle and a good spare tire in the trunk. In the problem now, they have specified what's the initial state. Initial state, they have told you that there is a flat tire present at the axle of the car and there is a good tire present in the trunk of the car. So this is the initial state they have given. Further, to keep it simple, our version of the problem is very abstract one with no sticky tugs, nuts or other complications. So that's what they're telling you to make it simple. You ignore that, nuts and bolts have to be tightened and all that you forget. Okay. Now there are just 4 actions. 1. Removing the spare tire from the trunk. So they also specified what are the actions. 1. Removing the spare tire from the trunk. 2nd. Removing the flat tire from the axle. 3rd, putting the good spare tire on the axle. And 4, leaving the car unattended overnight. Correct? Now, we assume that the car is in particularly bad neighborhood, so that the effect of leaving it overnight is that the tires disappear. So then they are asking you to design a strips representation for the above problem. So for exam, they give this kind of paragraphs, okay, and you have to figure out what is the initial state, what is the goal state, and so on. So initial state is very clear here. Now the goal state is what? The goal state will be to have a good spare tire properly mounted onto the car's axle is a goal state. So initial and goal state is given here, and they also told you what are the actions that you can take. 4 actions are mentioned. So now, how do we represent this in strips? Strips, like programming language, strips has a particular style. So to specify the initial condition, we use a keyword called as init. Okay. So we write init, and then in the bracket we specify the predicates. They should be true. These are the preconditions for that particular strips script to be executed. So what they've specified, initial condition, they specified that flat tire should be at the axle and the spare tire should be at trunk. So this particular problem of changing the flat tire, this script of strips will be executed only when the initial state contains a flat tire at the axle and a spare tire at the trunk. Only then this script will be executed. So this is the first line of the strips representation. Okay, init is the keyword. Within these brackets you have to specify the initial states, initial conditions of the initial state, initial axioms. Now before writing this, it is always better that the student specifies that what are the different predicates that you are going to use. For example, you can specify I am going to use at predicate something comma something, where what is the first parameter, what is the second parameter. You can just write that, okay, for the examiner to understand. Now goal state, to specify the goal state there is a keyword called as goal. Now goal state is what? They have specified that goal of the problem is the spare tire should be fixed at the axle. Okay, now so this is how initial and goal state has to be represented. So first 2 lines of the strips representation will have initial states written like this and the goal state written like this. Now how to write the action? The first action, so keyword for action is action. Okay, so you see this is the opening bracket, this is the closing bracket, and your action will come within these brackets. Okay, now the first action is remove action. Remove what? Spare tire is removed from the trunk. Let's say this is the action that I'm going to represent. Spare tire is removed from the trunk. Notice the comma. Now for this action, what is precondition list, what is add list, what is delete list, you have to specify. Okay, so the action, the first action that we are considering is spare tire should be removed from the trunk. Now for this action of removing spare tire from the trunk, what should be the precondition that should be true? First of all, spare tire should be there at the trunk, no? Only then you can remove it. If there is no spare tire in the trunk, how will you remove it? So the precondition here is spare tire should be at the trunk, right? So this is precondition. Now let's say spare tire, this action is already executed. Say spare tire is already removed from the tank. Then what are the effects? So see here, we are explicitly specifying that removing the spare tire from the trunk means that after that action is taken, post condition, the spare tire is no longer present in the trunk. This is what I was talking about in the Green's approach, right? So here we are specifying that since spare tire is already removed from the trunk, the effect of that in add condition, you have to specify that spare tire is no longer present in the trunk. Okay, now if it is no longer present in the trunk, then where it is? So and where it is, spare tire after removing it from the trunk, currently it is on the ground. You have not yet fixed it onto the axle. Okay, and delete list contains all the predicates from the precondition list which are no longer true after the action is taken place. So after spare tire is removed from the trunk, is this predicate still true? Is spare tire still present at the trunk? No, it is not present in the trunk. So this predicate is false now after the action is taken. So this predicate from the precondition list has to be added in the delete list. So what should be contained in the delete list? All the predicates in the precondition list which are no longer true after the action is taken, they have to be written in the delete list. Add list will contain all the effects of the action. Precondition will have all the preconditions for the action, right? So closing bracket. So this is the first action called as removing the spare tire from the trunk. Next action is, let's say, removing the flat tire from the axle, right? So comma. Now when can you remove the flat tire from the axle? What should be the precondition? First of all, the tire should be flat from the axle, otherwise somebody will call you mad. If the tire is not flat, why are you going to remove the tire from the axle, correct? So the precondition for removing the flat tire from the axle is that flat tire at the axle should be flat, it should be punctured. If it is not, why are you going to remove it? Next, what is the effect of this particular action? As I have mentioned here, you need to specify that once flat tire is removed from the axle, it is no longer present at the axle. You have to explicitly specify this. And now if it is not present at the axle, then where is it? Flat tire is present at the ground, correct? And delete list contains all the predicates from the precondition list which are no longer true. So after removing the flat tire from the axle, is it still present at the axle? No. So this is false. So write this. Okay. So this is how you can represent the action, second action in the strips representation. Third action is put on action. Okay. Put on means what? Now that the spare tire is removed from the trunk, flat tire is removed from the axle. Now you are putting it onto the axle. So I've just used a predicate called as put on. That's what I was telling you. Before you start writing this the strips representation, you have to write that I'm assuming a predicate called as put on which will do so and so thing. Then I am assuming the predicate called as add flat comma axle which represents so and so. So you have to write all these predicates whatever you are assuming, and then you start using those predicates. Okay, there is no one way you can give them any names, but you have to tell the examiner what a particular predicate means initially, and then start using those predicates in the strips representation. Okay, now the next action is put on spare comma axle. Okay, what is the precondition of putting the spare tire on the axle? Correct. So if the flat tire is already present at the axle, can you put a spare tire on top of it? No. So the flat tire should not be at the axle. Okay, so that means the flat tire must have been already removed, only then you can put on the spare tire to that axle, and spare tire should be at the ground, correct? These are the two preconditions for putting on the spare tire on the axle. Now, after the spare tire is already put on the axle, what is the effect of that add list? Effect of that action? Effect is that the spare tire which was earlier on the ground as a precondition, now that spare tire is now present at the axle. So there is no longer a flat tire present at the axle. And now, see, spare tire was at ground. Now we have put it on the axle. Do you also have to specify the machine that since spare tire which was on ground now on the axle, does it mean that spare tire is still no longer present on the ground? Yes, you have to explicitly tell him. So the effect of the put on action is the spare tire is at the axle and the spare tire is no longer present on the ground because now it is at the axle. Earlier it was on the ground. Understood? So you have to specify what is obvious also. Now delete list contains those predicates from the precondition list which are no longer true. Now after putting on the spare tire on the axle, is there a flat tire still present at the axle? No, this is false. No, now there is flat tire on the axle, so there is no longer flat tire present on the axle. This is false. So add this to the delete list. Agreed? Is the spare tire present at the ground? No, it is already at the axle, so this is also false. So add that. And finally, the action of leaving the car overnight. They have purposely given you this particular action because they have not specified there the reason why you left the vehicle overnight. It could be anything. Okay, reason for taking this action, that is leaving the car overnight, could be anything. Maybe along with the flat tire, okay, you may not be having a particular tool to remove the tire and fix the good tire. One, that could be the reason. Second, maybe your hand may be injured and you require a mechanic. Third, it could be something like the area is spooky as because it's a I told you what kind of area it is. Okay, it is a bad neighborhood. That's what we said. So it can so happen that by the time the tire got flat, suddenly he saw another car approaching, and he told the driver that since I don't have I don't have tools, can you please take me to the city? I will take a mechanic from there or something like that. Anything can happen. Anything, right? So these things are not specified, and that's why here the preconditions for leave overnight action I have kept it blank. A student may write one of these conditions, okay, but unnecessarily when something is not specified, you may not write it instead of wasting time, correct? So since the precondition for this action to be executed is not specified, there could be any precondition, so that's why we have kept it blank. Now see, if the car is left unattended overnight, what can happen? They have told you the effect of leaving it overnight is that the tires disappear. Okay, they have clearly told you that the tires disappear. That means spare tire is no longer present at the ground. You won't find a spare tire on the ground. You won't find a spare tire at the axle also, and you won't find spare tire in the trunk also, right? That means the spare tire, that means somebody has stolen the tire. The effect of this action, when you come next morning and check, spare tire you will not find it on the ground, nor at the axle, nor in the trunk. And the flat tire also you will not find at the axle and not at the ground. That means somebody has stolen flat tire also, because it is clearly said tires disappear. Okay, and now what are you going to write in the delete list? Since there is no precondition specified here, then delete list also will be empty. Fine. So this is a very simple representation. This is how the strips representation can be written. Another thing, students, please don't get confused. Just because I have written the remove action first, then this remove action, then this put on, and then leave overnight this action. Whenever I write action, these actions, they don't specify a particular order of execution. They are not showing the planes. We have simply represented each action with the strips representation. Now to come up with a plan to solve this problem, you require something else. What you require is a planning. We call it as goal stack planning or linear planning. Goal stack planning is an algorithm that we are going to use in this linear planning. So this representation, this strips representation of actions, this will be given as input to that goal stack, and the goal stack at the end, after the end of the algorithm execution, will give us the plan. Which action should be executed first, which action should be executed next. That plan will be given by goal stack plan. Here, this is just the style of representation of strips. So then this strips style representation can be given as input to the goal stack. Fine. So I conclude with my today's lecture. In the next lecture, we will see what is goal stack planning and how we can use it to solve the problems. Thank you very much.